Is the function f of x odd? In other words, does it have odd symmetry? For odd symmetry, there's a test like there is for even symmetry, and it even starts out the same. For both tests, what you do is you put in negative x. And you remember, when we were talking about even symmetry, what we were hoping to see is that the function came out totally unaffected, that it was just f of x with no changes at all. To be odd symmetric, you have to be just like the original function with no changes at all, except for a single negative sign out front. No, let's see if we can make that happen. Well, we're not going to make it happen. Let's see if that does happen. Here is our original function. If we do f of negative x, that means we get negative x to the fourth power minus 2 times negative x. This is negative x times negative x times negative x times negative x comes out to positive x to the fourth. And then we get negative 2 times negative x makes plus 2x. This is not our original function, so we don't have even symmetry. What if we get clever and factor in negative 1 out of this? Does that do anything? Or I'm not going to put negative 1, I'll just put negative. That would mean we get negative x to the fourth minus 2x. Nope, that didn't do it either. Now the negative 2x is good, but the x to the fourth has the wrong sign. There's really nothing we can do to turn this f of negative x back into the original function with or without a negative sign. Therefore, no, this function does not have odd symmetry. Have you wondered why they're called even and odd? There's a simple reason, and it's actually kind of helpful. A function has even symmetry if it's only made up of even powers, or a polynomial has even symmetry if it's made up only of even powers. And a polynomial has odd symmetry if it's only made up of odd powers. This polynomial is made up of one even power and one odd power, and when you have a mix like that, you end up having no symmetry at all. You have one term that's trying to be even symmetric, the other term's trying to be odd symmetric, and they conflict, and you end up with a function that's totally asymmetric. So if this were x to the 4 minus 2x to the 2, both terms would have even powers and we'd expect even symmetry. If this were x to the 3 minus 2x, the powers would be 3 and 1 and we'd expect to see odd symmetry. So in some cases you can eyeball the symmetry just by knowing how the powers behave. But the best way, the way that we really want you to learn, is this negative x technique, because this works even for things that aren't polynomials.